everybody, and welcome to your lesson today. This is 331, division with rational numbers. So you talked about the other day about this warm-up right here. So simplify each fraction expression. What do you notice? I believe this is in math notes, but I'm not quite sure. I think so. So 5/4 times 4/5 and -2/8 times 8 over -2. So give this a try. Pause the video, come back in 2 minutes. Ready to go. Okay, so we multiply straight across, we multiply fractions. 5 times 4 is 20, and 4 times 5 is 20. 20 over 20 is 1. For the next one, -2 times 8 equals -16, and 8 times -2 is -16. -16 over -16 is 1. So what you should have noticed is that they were both 1. And you should have noticed also that you're multiplying by the reciprocal, which is when you take a fraction and you flip it. That's the reciprocal. And I believe the math notes yesterday said the multiplicative inverse, and that just means multiplicative, multiply, inverse. We're talking about the reciprocal. And so when you multiply a fraction by its reciprocal, you get 1. Homework answers, feel free to pause the video and check these now. Today's lesson objective: students will understand what a rational number is and that any rational number can be written as a division problem and vice versa. They will divide fractions, mixed numbers, and decimals. So how can I divide? A fraction is really just a symbolic representation of the quotient, which is the answer to a division problem, of two quantities. The fraction 3/4 really means 3 divided by 4, which is just 0.75. In this lesson, you will work with dividing fractions, positive and negative mixed numbers, and decimals. Question 87. A rational number is any number that can be written as a quotient or fraction of integers, that is, in the form a over b, with the denominator not equal to 0. Please write that down in your notebooks. Rational number is a vocab word. So a rational number is any number that can be written as a quotient or fraction of integers, and you can just write a over b and then write next to it denominator does not equal 0, because we can't divide by 0, right? We think about putting things into groups. So if I had 10 things and I divide them by 2, that'd be 10 things putting into 2 groups. If I did 10 divided by 0, I have 0 groups. I can't split them up, so I cannot divide by 0. Okay, so we look at this question though, and we have a bunch of pencils. Okay, we have 1, 2, 3, 4, 5, 6 pencils. Now, it's asking us to first split these evenly into 3 groups. Okay, well, here's a group, here's a group, unlock it. Okay, here's a group. Oh man, that's 2 groups, that's 3 groups. Put another pencil in group 1, another pencil in group 2, and another pencil in group 3, and they're all done, right? So how I would write that is 6 split into 3 groups is going to give me 2 per group. Okay, so that's the first one. The second one says now split them into 2 groups. Okay, well, that's 1 group, that's 2 groups. Group 1, group 2, group 1, group 2. So if I took 6 and split them into 2 groups, I would get 3 in each group. And then it says now split them into 0 groups. What happens and why? I just said it. You can't split into 0 groups. 0 groups is not a thing, so I can't do it. I'm unable to do it. Unable to divide by 0. Okay. So it says, what mathematical operation does a fraction represent? So a fraction represents one mathematical operation. Okay, it's kind of given to you. What is it? Division. It is division. It represents division. We talked about taking fractions like 1/2 and changing it to a decimal. We take 1 divided by 2, right? That's what it is. So with your team, you don't even need 2 minutes. I'll give you 1 minute. 1 minute, pause the video, and you are going to do these 3 problems, and all you're doing is you're just changing them to fractions. It says represent each division problem as a fraction. So pause the video, 1 minute. Go. All right, 2 divided by 8 is 2 over 8. 72 divided by 5 is 72 over 5, and 51 divided by 94 is 51 over 94. Now you could simplify them, but we're not going to. 88. Think about how you rewrote the division problem above as fractions. This can also be done with negative rational numbers or negative fractions. Is this different from this, and this? I want you to think about it first. We'll do a TPS, think, pair, share. I want you to think about it first. And then you're going to talk with your team and you're going to decide yes, no, or I don't know. And you need to do it for all three. Okay, so we're asking, is this fraction right here equal to this one, and this one? So think to yourself for 30 seconds and then talk to your team for a minute to make sure everybody has the same answer. So pause the video. All right, so negative 2/3 is how I would read this one, and that just means that the whole problem is negative, or the whole fraction, excuse me, is negative. Okay, for this first one here, then we have negative 2/3. The negative is up top. We definitely are able to do that. If I did negative 2 divided by 3, I would get negative 2/3. For this one, if I did 2 divided by negative 3, I would get negative 2/3. But if I did this one and I did negative 2 divided by, oops, that's not a negative. If I did negative 2 divided by negative 3, I would get positive 2/3, because taking a negative and dividing by a negative is actually going to give us a positive. So this is the only one that it does not equal, but it does equal these two. Now, in math, sometimes we have grammar, right? And so this is one of those grammar pieces. We usually don't put the negative in the denominator, okay? We either put it out front or we put it up in the numerator. It means the same thing, so it's not like you can't do it. It's just, like I said, it's kind of that math grammar part of it that doesn't really make sense to put it there. All right, so I'm here after school. 89 says, Huey, Madison, and Ramona were working the following problem, and each began her work differently. So the problem is 1 3/8 divided by 3/4. They each show their own way, and they explain their own way. What you are going to do with your team is you have 10 minutes. It's a long time, okay? But 10 minutes to look at these ways, really dissect them, and see if you can figure out what they're doing, okay? Your jobs are right here. They're listed. Nope, not that direction. There we go. They're listed below, and you know what you're doing, right? So we are figuring out on question 89, just read through the work, see if it makes sense, see if it doesn't make sense, right? Ask questions, but work with your team to figure out what way you like, what way makes sense, and we're going from there. So pause the video for 10 minutes. Go. Okay, you're back. Hopefully you found one of the 3 ways that made sense to you, and we're going to talk about them. So personally, I'm not a fan of Ramona's way. I don't like it. I don't think it makes sense, and it's not tangible forever. So I don't like it. I'm not going to use it. If Ramona's way was the only way that made sense to you, you can explain it to me in a way that makes sense, and then I will use it. But for today, I'm not. I'm going to show you how to do one of these in Huey's way and the other one in Madison's way. Okay, so for this question, okay, you are going to work with your teams. You're going to pick whatever way you want to do. If you like Huey and somebody else likes Madison and somebody else likes Ramona, that's fine. Everyone do it the way that makes sense to you. And then after, come together, get an answer. It does say pick an approach. Pick one. Don't do both. Don't do all 3. Pick one approach, get an answer, move on. Okay? So you have 2 problems to do. Do both of these, and then come back from the video. I'll give you about 5 minutes. Okay? So pause the video and come back in 5 minutes. Are we back? Okay, so I'm going to do Huey one way and Madison the other way. So Madison's way is, if you recall, I'll go back. Madison was getting the common denominator, and then she divided across the top. So if I do Madison's way for this, I have 4/5 divided by 1/2. So a common denominator for 5 and 2 is 10. So I use 10. 5 times 2 is 10, so 4 times 2 is 8. 2 times 5 is 10, and 1 times 5 is 5. Okay, now I have a common denominator, so I'm just going to divide across the top. So 8 divided by 5, if I write that as a fraction, that is 8/5. 5 can go into 8 one time, and 3 will be left over. So my answer is either 8/5 or 1 3/5. For the second way, or the second problem, I'm going to use Huey's method, and Huey did the giant 1 is what he called it. So I'm first going to change 2.5 to a mixed number, or to an improper fraction. So 2 times 2 is 4, and 4 plus 1 is 5. So I have 5 halves divided by 3/4. Now, just like we can write this problem as a fraction with the first number being the numerator and the second number being the denominator, I can do the same thing for these fractions. So 5 halves is my first number, so that's the numerator. And then instead of divided, it's a fraction over my denominator. Now that's messy, so now I need to create my denominator of 1 so that it goes away. Because if you think about whole numbers, 5 is really the same as 5 over 1. We just don't have to put it over 1 because it's divided by 1 and that's just 5. So we leave it. So that's what our goal is here, is to get a denominator of 1. And so just like in any fraction, whatever we multiply the bottom by, we have to multiply the top by, so we're going to do that. And this brings in our warm-up of multiplicative inverses, because to get 3/4 to equal 1, I have to multiply it by its reciprocal. So 3/4 flipped is 4 over 3. And like I said, whatever I multiply the bottom by, I have to also multiply the top by. And if I'm multiplying 4/3 over 4/3, that's where they get that giant 1 from, because 4/3 over 4/3 is just 1, right? I'm not changing the value of this fraction, I'm just rewriting it. So now if I multiply across, I'm going to keep this here. So I have 5 halves times 4/3 is my numerator, and my denominator is 3/4 times 4/3. If I were to multiply 3 times 4, I get 12, and 4 times 3, I get 12. If I multiply 5 times 4, I get 20, and 2 times 3, I get 6. So now I have 20 over 6 over 12 over 12. Well, 12 over 12 is just 1, and now I don't need that there anymore. So I just get 20 over 6, which I can simplify. I can divide them both by 2, and I get 10 over 3. And that is just 3 1/3. So that's what you should have gotten for that one. No matter what way you did it, that's what you should have gotten. So some ways make more sense than others. Some ways are quicker than others, and some take a little bit more time, but whatever it is, it's got to work for you, right? You are the only one that's doing the math, okay? On a test, it's you. In real life, it's you. So find a way that makes sense. Find a way that works, okay? These are the 2 ways that I like to stick to, and I will be alternating in math during class, talking about Magnuson and Huey's way, okay? Now, oh, nice. I already had the answers already done. So cool. Didn't even realize I had prepared that. So here we have closure, 4 minutes. Pick the strategy that works for you. Hopefully something is making sense now. So pick a strategy that works for you. Go for it. And pause the video, come back in 4 minutes. Okay, we're back. And I do remember that I have the answers for this one. So it's kind of choppy because I took a picture of it, set it on paper, but same thing. So here we have Madison's way. We did a common denominator here. So we got denominators of 24. 8 times 3 is 24. 17 times 3, I did that over here. We got 61. So then I had to do 61 divided by 8, which is just 61 over 8. And then made sure I changed it to a mixed number. So 7 7/8, negative 7 7/8. And then I also showed you Huey's way, which is the giant 1. So if I'm dividing by 1/3, I multiply by 3 over 1, both the denominator and the numerator. I end up getting 3 over 3 on the bottom here, which just equals 1. So I end up with negative 61 over 8, which should look familiar from over here. And then that's the same thing, negative 7 7/8. So either way, that should have been the answer that you got. And again, if you did Ramona's way, yay, you. Fraction division, another example. It's showing you method 3 using the giant 1, using a super giant 1. And you can look at that if you have some more, if you need some more help with Huey's way. Okay. Homework tonight's 93 through 97. Thank you so much for being awesome math students, and I really appreciate you, and I will see you soon. Bye-bye.